Hi everyone, hi teacher. I'm Wanying. My partner is Xu Yinbo. Today I'm gonna talk about integration large language model into computer program education to help students learn better. AI is still developing super fast in education these days, and large language models like ChatGPT and GitHub Compiler are starting to be used in programming classes. Unlike the old ways of teaching, like lecturing textbooks and waiting for teachers to give feedback, this modern can answer questions quickly, explain things simply, and help solve problems through iteration. They make us wonder, how do these modern affect how will students learn, compared to the dictionary method? Literature review. Sadly, more and more people are paying attention to using AI, especially large language models in programming education. Studies have shown that tools like ChatGPT and GitHub Compiler can give instant feedback, create practical problems, and make evaluation easier, which helps students learn better. Zheng and another 2023 compared to old measure. They made debugging faster and lessing the measure, so students can focus more on solving bigger problems. But Schooler also says there are risks if students rely too much on AI. They might just learn such basic stuff, nothing critically enough, and get worse at solving problems. Next, we set for research question. One, does the integration of LLM into programming education lead to sustainable and beneficial learning outcomes in programming skill acquisition? Two, to what extent does the use of LLMs positively influence students' mastery of programming skills? Three, to what extent do LLMs improve learning efficiency, efficiency compared to traditional learning measure? Four, what pedagogical strategy best align with LLM integration in maximize learning outcomes in programming education? Three, methodology. We did a SLR for this study following the PRISMA guidelines. We went through a step-by-step process for finding, screening, and picking study to make sure everything was reliable and clear. Looking for literature, we searched in three big academic databases: Scholar, Web of Science, and ERIC from 2021 to 2025. Cited when these AI teaching tools started popping up a lot. When used keywords like large language model, ChatGPT, GitHub Copy, programming education, coding skills, and learning efficiency. Screening experts, we find 4,568 papers, out getting rid of 1,024 duplicates. and 3,544 were left to check. We look at the title and abstract and carve out 3,112 that didn't focus on programming education, large language models, or didn't have really research data. That leaves 432 to read finally. In the end, 405 where is collapsed because they were just ideas, know about large language models and so on. Only 27 made a cut for our analysis. We also did experiments. We used the study trap data set from Hugging Face, which have 1,197 conversations between students and large language in programming classes. Linear regression, we got an R-squared of 0.4136, which means the model can explain things pretty decently. Okay, next, my part time.
And my partner has given a brief overview of the research, the methodological, and I will provide simple explanations of the uh, algorithms used in this study. In order to explain the effect of the LMS, we used the study chat data type from the Hugging Face, which contained 1,197 student dialogues. Yeah. We appealed multilinear regression with the dialogues, behaviors, and server response as the predictors and student performance as the outcome. The regression model predicts student performance based on the dialogues, behaviors, and server results. At first, I must explain the uh, expand the circle right, and the coefficient, determination. The R circle right shows how much of the variations in performance the model can explain. It is calculated as one minus the ratio variance over the total variance. Um, we faced ChatGPT along this experiment. Yeah. When ChatGPT used was alone, the R circle right was showed 0.4136. Meaning the model is explaining about 41% of the variance in performance. In contrast, for example, without ChatGPT, R circle rate, I can't get a nice end because I don't have the suitable database. Um, Maybe the next step experiment we can change it. Um, the funding, we can see this results suggest the MMS modalities enhance the efficiency in coding test. Student benefits from the quicker complication. But the exam reveal deeper scales and more stronger try to the prefactors. Thus, MMS should be seen as a accelerators rather than the replacement and fundamental learning. And we faced some I faced a challenge. One of the major challenges is the pedagogical agent. Uh, I- we one of the major challenges is the pedagogical element. Without well-designed teaching structures, Students may misuse the MMS as the shortcuts rather than the general learning tools. Another challenge is the ISICs. Concerns about the fairness is assessment and the data provide continue to complicate their adoption in education. In the summary, we fixed the summary. Summary. So overall, the summary based on the multiple studies, the findings suggest that MMS are powerful accelerators of the programming education, in providing absence and providing the valuable coding support. Yes, their effect depends heavily on balanced integration and guiding use. Without the careful instructional the strangers they risk undermining deep learning and fundamental skill question. Yeah. Your future research we will first establish the more predicate control groups in the preliminary experiment present in this paper. The control groups were insufficient, and the data analysis could only confirm the existence of the qualification. As a next step, we plan to conduct a multiple small sample studies to examine the in a greater deeper the extent to which MMS enhance the learning efficiency in programming using data that more closely reflect the actual classroom context. Thank you, Professor. Thank you, Professor.